digital signal related projects in Matlab, generally we require to generate some basic signals like impulse signal, unit step signal and unit ramp signal. So in this particular video we will learn how to generate these basic signals in Matlab. So first we will start with the unit impulse signal, and then we will move to unit step and unit ramp signal. So before generating the any signal, first we need to define the time stamp over which we need to generate or over which we will define the signal. So we are taking the time stamp from minus t to plus t at the difference of 1, and in this case the t is because it is a digital system, so everything is in sampled form. We will taking the samples from minus 10 to plus 10 at a difference of 10. After that we will generate the signal. As from the definition of the impulse signal, it is clear that impulse signal exists only at point 0. At the all other values it is 0. So from minus 10 to minus 1 it will be 0, and those zeros will be generated by a command 0 1 10. So this 0 1 10 will generate a row vector, a single row vector having 10 elements, and all those 10 elements will be 0. This will go from 1 to 10, and then we will generate ones at 11th location, because 0 will be at the 11th location in n vector, and then ones because we want to generate only one value, so that's why it will be 1 1, and then again zeros for rest of 10 values. So if we now plot impulse, it looks like a triangular way, but this is due to the fact that Matlab by default interpolates all the sample values. So for better display we need to use stamp command, and now we look at the values. Now we are getting the one signals, only one sample value at the 0th location, but it is going from 1 to 21 as the row vector is of 21 length. So for displaying purpose, in order to make it more beautiful or more informatics in the sense, we will generate or we will plot a two-dimensional stamp plot, the sample values over which we are generating and the signal value, and then we will define the x-axis or the x label like time stamp, and y label as the amplitude value. So now if we see it, we are getting a response at 0, and all other locations the sample value or the signal have 0 values. So this is clearly a unit stamp signal, unit impulse signal in discrete time domain. Now we will generate our unit step signal. The unit step signal is very easy. Again, first we need to define all those time stamp, and then step signal can be generated directly by step. First the zeros value up to minus 1, so that means for starting 10 values we will be having zeros 1 10, and then all the rest for rest of the time duration we will having 1. So the rest samples are 11, so we will generate ones over there, and now we can easily see the signal stamp and comma step, and again the x label of time axis, or we can say because it is in discrete time, sample axis, and Y label as the amplitude. So it is a unit step signal in discrete time domain. For more visual, for making it more clearly visible, we can also do one thing, we can also display the grid. That can be displayed just by simple command grid on and then enter. So grids will be visible here, and now it can be easily denote like up to the value 0, it is 0, and adds at from starting from 0 to onwards its value is 1. So finally, in this video we have generated unit impulse signal and unit ramp signal.